This is a real formula. 1 over uppercase R equals 1 over R1, R subscript 1 we would just call R1, plus 1 over R2. Anybody recognize that formula? Not that it matters, but it's a real formula that people use it every day. It gives you, or it relates the total resistance, capital R, with two resistors, the resistance given by R1 and R2 in an electric circuit when the resistors are connected in parallel. So you can use this equation to get capital R, the total resistance. You don't need to know any of that. I don't mean to scare you, right? But these equations are actually used for something many times. So we're solving for capital R. This is a rational equation, isn't it? So what was one of the things we studied just the other day for solving rational equations? We multiplied through by the LCD. We're going to do the same thing here. We're going to multiply through by the LCD. Let me rewrite this equation so the original one doesn't get all messed up. So let me rewrite this thing. Does capital R, R1, and R2, do they have any common factor that we know of? As far as you can tell, they don't have a common factor. Let me put it that way. What's the LCD of capital R, R1, and R2? Well, don't we just multiply them together to get the, yeah. So it's the same idea. So one of the rules we've been applying is multiplying through by the LCD in order to clear the denominators, right? So that's what we're going to do here. We're going to multiply through by the LCD, both sides. Now, what is the LCD? I said it, but I didn't write it down. What is it? R times R1, R2, right? You multiply all the denominators together. When they have no common factors, you multiply all the denominators together to get the LCD. And that's, okay, I'm going to multiply the left-hand side. That's going to get rid of the R in the denominator, right? But to balance that out, so that's reversibility, but to balance that out, I'm going to multiply the right-hand side by the same thing. Balance principle. Okay, so let's do the left-hand side. That's easy enough. What's going to be left after the division?
R1 times R2.
Yeah, R1 times R2. R1 times R2. Now, on the right-hand side, what do you have to do? Since it's a sum that you're multiplying times the LCD, you have to distribute. So this R times R1 times R2 ends up in the numerator of both of those fractions. Does everybody see that? I'll write that as, since you have a 1 in both numerators, it's just going to be 1 times R. Whoops, that's a R. And then an R1, and then an R2. And then that's going to be over R1. So that's the first guy, right? That's what you get on this guy when you multiply out the R times R1 times R2. Everybody agree with that? And then on the next guy, plus, okay, again, just 1 times that LCD in the numerator divided by the R2. Does everybody see what I did? Does everybody see why the denominators are going to go away? That's critical that you see that. So what's going to be left from this first term on the right side? R1 divided by R1. So capital R times R2. And then what's going to be left from the other term? R times R1, right? Okay, so let's write down the simplified version of this equation. We have the R1 times R2 on the left side. R times R2 plus R times R1. So all I've done is clear the fractions, right? Clear the denominators. Now we're trying to solve for uppercase R, right? I see uppercase R appearing twice on the right side. Do you see that? We need to get a single uppercase R. Can anybody think of a way on the right side, a technique you've been using a lot lately, to get a single R? We could factor it out. We could pull it out, you guys. So the idea would be, oh, okay, pull out the R, undistribute it. Pull out the R, what's left?
R2 plus R1.
R2 plus R1. Now, had we been paying attention I suppose we spun our wheels a little bit here. Had we been paying attention, we could have just distributed R1 times R2 in that step where we distributed the entire LCD, and then we'd already have the R on the outside, but I wouldn't expect you to see that ahead of time, right? I wouldn't expect that. So we spun our wheels a little bit in that, but no big deal. Everybody with me to this point? I mean, maybe you couldn't have done this on your own yet, but are you do you understand the steps we follow? That's what's important right now. If you have questions, ask. Okay, how is capital R connected to the quantity R2 plus R1, which is left inside when we factor out that R? Multiplication, so how do we disconnect it? Divide. So we get R by itself. We undo that. We reverse that multiplication by division. And then balance principle says do it to both sides. So divide both sides by R2 plus R1, or you could say R1 plus R2 if you want the numbers to go in order. Now you can see what's happening here. The R2 plus R1 cancels as an entire quantity, right? On the right side. And then you're left with R. So let's turn it around. Let's turn it around. I'm going to put the R on the left side. And then R1, R2 divided by, you can write addition in any order you want, right? So I'm going to rewrite that R2 plus R1 as R1 plus R2, not that it really matters. I just think it looks a little better.